Hi, Ron. Thanks, Kevin, for that really interesting talk. I'll hopefully be able to not repeat things, but maybe sort of move things a bit further. But my name's Angela Masurier. I work at ITOP. For those who aren't aware of what ITOP are, we're a not-for-profit scientific advisory organization that responds to chemical and oil spills around the world. We've been functioning for 55 years now. We've attended, I think, every major oil spill from ships over the past 50 years. And yeah, we're looking now into alternative fuels as sort of shipping moves away from, or sort of looks away from your conventional oils and looking into alternative fuels. So just, this is going to be more of the shipping side, but what is the future of shipping? So as Mark sort of mentioned, no one really knows. There are so many different variables. What we do know for certain is it's going to be a multi-fuel future. So we're going to see a lot of different ammonia fuel vessels, methanol, battery, LNG, LPG, all of those lots interacting with each other, and hopefully not colliding with each other, as that would be a bit of a nightmare. But it is something that the spill response industry just has to be ready for. It's not just sort of oil anymore. It's a lot of different variables that need to be taken into account. So I'll just be sort of going through that. It's basically a shift towards hazardous and noxious substances response. So I'll talk a bit later into what the implications of these are. So the different changes in time frames when it comes to response, changes in strategy, and then potentially changes in receptors as well when it comes to these different sort of fuel types. So just a quick thing. So basically the main sort of one of the main differences between H&S response and oil response is that one is hazard driven. So H&S is hazard driven and oil is behavior driven. So one of the things that we see when it comes to oil spill response is that it is whether the oil usually floats, but then potentially sometimes sinks, or what the sort of wind and current does to it. So it's the behavior that drives the response, and therefore we can work from there. However, when it comes to H&S, it's the hazard that drives the response. So whether it's flammable, whether it's toxic, what the different risks are depends on how the responder will be able to react to these sorts of incidences. So when we started this, looking back at 2020, I head up the alternative fuels sort of internal working group at ITOP. And when we started this, it was basically only focusing on low sulfur fuel oil because that was the main sort of risk at the time. However, as the IMO has sort of pushed on further with their climate change targets, we've looked at biofuels, LNG, LPG, ammonia, methanol, and hydrogen mainly. And then over the past few years, also looking at lithium-ion batteries. And we're even looking very much at a high level at nuclear, so small modular reactors, which are seeing a lot of interest in the media as well as within the shipping industry itself, which is slightly scary, and sometimes I don't really want to think about it. But I just thought I'd run through with you sort of the main differences. So, for instance, this was well, it wasn't a spill, it was an incident, a grounding incident off the coast of Uruguay. This is the Isla de Lobos. I probably pronounced that really wrong. Hopefully there are no Spanish speakers in the room. But it is basically a huge colony for South American fur seals and sea lions as well. And so this was a vessel carrying vegetable oils. And what I sort of want to just bring from this slide is that we acted as though this was a normal fuel oil because the characteristics are very similar. Yes, there are different biodegradation potentials when it comes to biofuel. So, for instance, FAME, which was mentioned before, as well as HVO, so hydrotreated vegetable oil, they are more biodegradable. And so because of their chemical makeup, it means that they're able to be broken down more by microorganisms. And so actually that may play a quite large role when it comes to their weathering, but they'll still predominantly float, perform slicks, or create slicks. And also when it comes to wildlife response, they'll look to smother the marine mammal in this instance, and affect its waterproofing and impact it that way. So the risks do seem sort of relatively similar when it comes to alternative fuels as a whole. However, then you have, I've lumped these in crudely together. They're basically gaseous in their normal state. So LNG, LPG, ammonia, and hydrogen. So obviously different degrees of volatility. So ammonia is stored at minus 33 degrees Celsius, LNG at minus 161, and hydrogen at minus 250. So they're, depending on their different boiling points, depends on how they'll react when they're spilled. And also performs their sort of storage requirements as well. So for instance, for hydrogen stored at minus 250 degrees Celsius, that is a lot of energy that needs to be produced to create a temperature that low. And so when they are spilt, they're likely to volatilize as they come into contact with their into ambient conditions, and so they'll start boiling over quite rapidly, and then they'll disperse over time. So those present their own risks. So LNG, LPG, hydrogen are very flammable. Ammonia less so, because the ignition energy is quite hard, so it's quite difficult to ignite. That's why when it comes to ammonia fuel engines, you need a pilot fuel to be able to light it, and then the ammonia kicks in afterwards. So flammable risks, ammonia, the main risk obviously is toxicity, as Kevin mentioned. So basically the different risks posed by these different fuel types are significant. And when it comes to the oil spill response industry, you're going to be asking a lot more different questions at the very initial stages in comparison to, okay, well, there's been an oil spill, let's grab all our boom, let's grab all our skimmers, and let's go there as soon as possible and try and collect it as quickly as we can, because that's not going to be the same in this instance. Methanol as well. So I've sort of separated this out, although obviously highly flammable and the risks associated with that. It is liquid in ambient conditions, does have a very low flash point of 11 degrees Celsius. So flash point is the temperature at which liquid produces vapors, which obviously increases the flammability risk. This was an incident in 2018 in Malaysia, whereby it was a methanol either offloading or loading, which then had an explosion. That then led to a subsequent release of HFO, which is what we reacted to. But we were able to actually sort of see that about a kilometre away from this explosion, there were claims for property damage from local communities. So it sort of gives you an idea of the geographical scale when it comes to incidents of these types. And the associated risks are similar in the fact that you may be walking into a flammable plume, or as Kevin mentioned, it burns with an invisible flame as well, which is sort of increases the risks. So just sort of the potential impacts between different sort of oil spills and these sorts of alternative fuel spills is that they'll be most likely more localized. You're not going to see for instance, an oil spill that reaches and impacts hundreds of kilometers of shoreline, like you would in a large incident. You'll see highly localized, but potentially higher risk, more catastrophic damage when it comes to these incident types. I mean, I put this up there just as a sort of scaremongering tactic. This is the port of Beirut following the warehouse explosion. But just to sort of put this into your head, that if there was a large explosion in a busy port area or nearby a populated center, there are quite significant risks regarding that. And so it's when I talk slightly later just about the shift in receptors potentially. It's just that is something that needs to be taken into account. I think I have a video here. This is just another sort of scaremongering tactic. Basically, it's in the port of Aqaba. It's a container of chlorine gas that was released. The crane broke, released one container of chlorine gas. Now, for those chemists in the room, chlorine gas is 10 times more toxic than ammonia, granted. However, that's just one container, and the risk, unfortunately, I think 15 people lost their lives, and I think over 150 were hospitalized following that. So it's just thinking about the different risks to human health and also not just the risks to the seafarers, but also the bunkering operators, the port workers, the nearby neighboring sort of population centers. So it's something that also needs to be taken into account when it comes to contingency planning. So just a quick, basically, the oil spill response industry was founded upon responding to oil, admittedly, obviously. So there may have to be a shift now towards how do we respond to these other fuel types. So it needs to have a risk-based approach. As I mentioned, rather than getting all your equipment and attending site or attending the incident, you may have to take into account your internal risk assessment before. You need to make sure that you're not sending people into a potentially toxic plume or flammable conditions or anywhere that you're going to be putting human health or human lives at risk. Potential exclusion zones. So that may be your modeling that needs to be taking place to try and model where the wind direction is, to try and find out where the different exclusion zones may be, to make sure that you close off the area to neighboring vessels if it is at sea, or also to potentially provide requirements for people staying in or to vacate or evacuate the area. So these are just some things that I thought I'd just put up there just to make people aware. Limited cleanup techniques as well. So containment recovery is obviously the goal when it comes to oil spill response. However, a lot of these fuels cannot be contained or recovered. Source control at best is, if it could be done safely, is the best scenario, but it may be that monitoring and evaluation is the only sort of option going forward. So and yeah, specialist response required. So you can't be getting your sort of local workers to come and help. You need to have a specialist team of people able to respond, and maybe Nick can sort of speak about that later. And then about timeframes. So basically, when it comes to the management of these incidents, because they're obviously very volatile, so it may be that by the time you're notified and you're trying to mount a response, that the risk may be over, or that the ship may have sunk, or that she may have lost her bunkers and it's all evaporated or volatilized off. So it's a lot more shorter term spill events in comparison to oil spills. The immediate need for information exchange. So between all the different stakeholders being able to say, okay, well, so the modelers being able to say, well, this is the model that is taking place. This is the area that's safe. Then it's the health and security agency who are then able to set up exclusion zones. It's then the fire responders, people who are going to be basically reacting. So it's basically just all this information between these different parties needs to come together and form a sort of cohesive response as much as possible. And as I sort of mentioned, certain level of information required before you can go into the to attend the incident. And then just I put this in just to sort of think about it. So when it comes to the different sort of receptors, so with an oil spill, you've obviously got human health. That is the initial, that's the first most important thing that needs to be thought about. And then it's the pollution damage which comes after. So trying to reduce pollution damage as much as possible, especially when it comes to sort of persistent oils, because it can have a sort of quite lasting effects on the environment. And then it comes to sort of the further down the property damage and the economic loss, which is obviously very important, but that's the sort of generally the scale when it comes down to those oil spills. However, for alternative fuel spills, you've got much more significant human health risk from the initial stages. And then where it's slightly flipped is that because of the potential very localized, very short level pollution damage that may be seen, it may be that property damage and economic loss sort of it replaces it at the sort of second level, because the fact that if there is an explosion, you may want to try and move the vessel away from as much sort of population centers, property as much as possible. So there is potential for those sort of that shift to occur, whereby pollution damage is actually seen as the sort of tertiary level because it's due to be so localized and short-lived. So I thought it would just be worth sort of noting that. Finally, I know I haven't got much time left. So preparedness, contingency planning. So there are sort of already established protocols in place. So The Marine H&S Response Manual, which is a QR code there that hopefully should work, is a really useful tool when it comes to responding to H&S incidents. And it's also just talking about the contingency planning that needs to be put in place. So having a tiered response that's scalable. So it may be that there is a very local risk at the beginning where a tier 1 response may be required, but then that may escalate. And so having retractable and expandable sort of response levels and contingency planning for that is really important. Scenario-based risk assessment. So for instance, if you have the Port of Singapore, for instance, is currently looking quite heavily at methanol and ammonia. So if you know that you're going to be having those risks in place of maybe an ammonia bunkering station, then you may want to look through the models and provide some sort of scenario-based risk assessment already so that you've got all that information in place in case there is an incident like that. And then obviously the primary focus being on the human health risks as well, which goes without saying. That's just some sort of model there. And then finally, training exercise is really important because we have, I mean, as Mark mentioned, there are a lot of, for instance, LNG fueled vessels currently, but they're mainly LNG sort of gas carriers. And so it's using the cargo to use as the bunkers. But these are very specialist people. The LNG, those working on LNG vessels, that's their bread and butter. That's their day in, day out. However, when you have then increased amount of vessels using different fuel types, and you may have a container ship running on methanol, then it needs to make sure that everyone is trained as well as possible to be able to sort of find the risks and make sure that they do everything that they can to reduce the risk to themselves, but also to potential spills and leaks. And then also exercises, testing timeframes, really important to make sure that information exchange is as rapid as possible. I think one final slide, sorry. Well, actually, we'll talk about that in the panel. We'll talk about it in the panel, but basically the fact that there is currently a gap within the international conventions when it relates to alternative fuels, because H&S convention, which is not in force yet, only deals with H&S's cargo, not bunkers. That's me. I've spoken enough. Thank you very much.